In our first example, then, and just to remind you, if you've taken a break between the two videos, that I'm defining the force of friction in terms of the coefficient of friction and the normal after something is moving or that split second before it starts to move. It's the only time this equation holds. And then I have two different types of coefficient of friction, or how sticky a surface is, if you will. This is kinetic. This is related to motion. Oh, I don't want to use the same color. This is related to motion. When it's in motion, I have kinetic. And this is when it is still. So I can do a number of things. I can solve for the coefficients of frictions for different surfaces based on different experiments. Actually, the most common one is to have something sitting on a surface, and I have this force meter that I attach to it. It's got a little spring on the inside, and then you attach it to the object that you're wishing to measure. And you start applying the force just until it starts moving, because then we can use this equation to figure out what the coefficient of friction is between the two objects, which is very cool. So this one says this is moving at a constant velocity. It's a mass of 10 kilograms, and I'm applying a 5 Newton force. Really important. We're always going to start with our free body diagram. So I have the force of gravity down. I have the force normal up. In this case, they are completely 180 from each other because it's a flat surface. And I have this force applied going this way. Now here's the hint. We are solving for the coefficient of friction. Yeah, the problem should explicitly state that there is friction here. So the one thing that's missing from this is that I have this coefficient of friction, or this force of friction rather, opposing this pole, opposing the motion. So let's write out our free body outside of the picture. So what does that give me? That gives me, let's see, a force of gravity down, a force normal up, a force applied that away, and that force applied is being opposed by this force of friction that away. Now let's decide what our sums look like. Now remember, this is it's moving, so it's defined in terms of its normal. So I need to make sure that I do a sum in both directions. So the sum of my forces in the y, oops, I didn't define. Let's just do the standard. Up and to the right is positive. So the sum of my forces in the y is my force applied minus the force of friction. Sum in the y. Okay, I've been doing too many of these videos today. Sum in the y. Let's try that again, shall we? Is the force normal minus the force of gravity, and that equals 0. Not flying up in the air, not falling down to the ground, it equals 0. Now let's do the one I was starting to do. The sum of the forces in the x. That is, the force applied is in the positive direction as I've defined it. The force of friction is opposing that. And that equals, what was that? What does that equal? Is that MA? Because I kind of feel like at constant velocity, it's not accelerating. Yeah, as a matter of fact, at constant velocity, that means the sum of these forces is a big fat 0. So I'm going to bring that on up here. So my force applied equals my force of friction. Now pay really close attention to the questions that you get, because for some of them, this is all they want. If I know what this is, well, gosh darn it, I can go right for the force of friction. I know it because they're equal. But this is asking for the coefficient of friction. So if I want to get to that, I need to look at this in terms of the force normal. So the force of friction equals mu times Fn. Well, I came down here, force normal minus force gravity equals 0. So force normal equals the force of gravity. So I have the force of friction equals mu times the force of gravity. So I can rewrite this, putting the force of friction in here, and I get that the force of friction equals mu times, force applied equals mu times mass times gravity. So I want mu, so let me rewrite that. That's a horribly, there we go, force applied divided by mass times gravity then gives me my coefficient of friction. So all I have to do is put numbers into that. My force applied was, did I even give that to you? 5 newtons. So 5 newtons divided by my 10 kilograms times my 9.8 meters per second squared. And that gives me my mu. That's it.